In this video, we're going to take a very short look at the parameter of pressure. Now, pressure isn't something we've talked about a whole lot other than kind of just in certain terms of things like vapor pressure or atmospheric pressure. So pressure, by definition, is the force that is exerted by a gas per unit of area of whatever it is that is coming into contact with. A container, a substance, whatever it is. Now, atmospheric pressure is the pressure that is exerted by our atmosphere due to the force of gravity. So you take all of the gases that are in our atmosphere, you account for the fact that gravity is acting on all of them, and that is what is creating the force um, for each of those molecules. Um, Now, we can measure atmospheric pressure through the use of something called a barometer. A barometer works in this kind of way. We've got an open pool of mercury, and in that open pool of mercury, we've got an evacuated, that is a glass tube that has had all of the air sucked out of it. So it's a vacuum inside the tube. And so what happens is when you put that evacuated tube into the mercury, mercury will start to shoot up into the tube, and it'll shoot up for as much pressure as there is being exerted on the open pool, to the point where we end up getting an equilibrium of sorts taking place. On one side, the height of the column, the forces that are pushing up, are the atmospheric pressure pushing down on the mercury from the outside. And on the flip side, we have pushing down the force of gravity on the mercury itself. And so these two will reach an equilibrium state, and that equilibrium state will result in the height of the column being stopped, essentially, and we can measure how high up the mercury actually went. And that becomes the basis for the measurement millimeters of mercury, or if we're using customary units, inches of mercury, um, or if we're paying homage to the guy who invented this, Evangelista Torricelli, then we're talking about torr, which is the same thing as millimeters of mercury. Now, when it comes to pressure units, there are lots of them, and I do mean lots of them. This is a relatively comprehensive list of the number of different types of pressure units that exist. We've seen a couple of them in action when we talked about osmotic pressure in chapter 11. But the basic idea here is that there are a number of different ways of measuring this. Now, in physics, you'll probably see more of the Pascal and kilopascal values. Here, we tend to focus more on millimeters of mercury, torr, and atmospheres. Sometimes we'll delve into bars and millibars. Weather forecasts tend to rely on inches of mercury, and we tend to see PSI, especially when we're talking about things like tire pressure, gauge pressures, those kinds of things. Now, all of these units can interconvert in between each other, and as we saw in chapter 1, anything that we can tie together with an equal sign, including all of these units to each other by the transitive property, we could use to make an effective conversion factor if we just had the existing values necessary. Now, before we conclude this relatively short video on pressure, I wanted to point out to you that a barometer is not the only way that we can actually measure pressure. We can measure pressure using something called a manometer as well. And a manometer, depending upon the system, works on kind of the same premise that a barometer does. So for example, if I have a closed system, and a closed system is a system where I've got an evacuated tube with closed ends on either side. What I will see is that in a closed system like this, when the valve is opened and the gas is allowed to fill the tank, the pressure of that gas is going to push that mercury up to some degree, and we'll be able to measure the height that it pushes that mercury up, and that'll be the pressure that the gas exerts, whatever that value is, however much the mercury climbs. Now that's a closed system. Closed systems are a little bit difficult to work with sometimes because, well, it's not exactly easy to get a completely evacuated tubing system like this. Far more common to use open systems. And in an open system, what we do is we have the same setup, but instead of the evacuated flask, we have a flask that is open to the atmosphere on one end and open to a gas tank on the other. And depending upon what happens to the height of the mercury, we can measure the pressure of the gas relative to atmospheric pressure. So if we've opened it up to the gas and the atmospheric pressure and it's all even, then we know that the pressure inside of the tank is equal to the pressure of the atmosphere. And that's actually probably not a very good thing at all if we're dealing with a gas tank, because that means that the gas tank, for all intents and purposes, is done giving us gas. On the flip side, let's say that the atmospheric pressure is greater than the pressure inside of the tank. And we see that the atmospheric pressure is pushing down on the mercury and making the tank side higher than the open side. Well, whatever this measured value is for the height, we can subtract that from atmospheric pressure, and that will tell you the pressure inside of the tank. And then finally, if the pressure in the tank is greater, it'll push the mercury up into the open end, and however far it pushes it up, we add that to atmospheric pressure, and that would give us the pressure of the gas inside. So that's just a little quick aside about pressure. When we get into our next series of videos, we're going to talk about gas laws, and we're going to do a lot of calculations involving those gas laws. Until then, have a good day.